Hello everyone and welcome to my video lab report for Lab 3. A star is orbiting a black hole of unknown mass located at the origin. The star has mass 2.30 kilograms. The position data, X and Y coordinates of the star will be generated in the starter code and the resulting trajectory will be unique to you. And we did this by using our Georgia Tech emails. Then the next step was to analyze the star's motion to find the net force of the star for all points in the data set using the scaffolding code starting on line 96. Assume the net force of the star is due solely to the black hole located at the origin and that the time between data points in your trajectory is 1 day. So to set it up, I started by plugging in the mass of the star and then the time interval, which is 1 day, but it's in terms of seconds. So there are this many seconds in a day. Next, I calculated the net force of the star in my code. And down here, I started finding the initial velocity and final velocity here, and then the initial momentum and final momentum here, and then the change in velocity, change in momentum, and then the dp over dt, which is the change in momentum over time, and then that was my net force. Then I also calculated p hat, and then I calculated the dp dt underscore par and that here, and use that to calculate the fnet par and the fnet perp. And when you run the program, I also went in and made sure I had the right arrows to show the forces. This is what the program looks like while it runs. And that calculates my fnet and my fnet par and fnet perp. And this is using a lot of Newton's second law and a lot of the formulas that we learned in class. Then I calculated the mass of the black hole, and this was done in the code here. The magnitude of fnet, magnitude of the star's position, squared times 6.6 e to the negative 11 times the star's mass. And that gave me the magnitude of the black hole, which was roughly 1.67 e to the 34. And it gives you multiple numbers for this because it's using average velocity when calculating this. So when you run the program, it puts out a bunch of different numbers, so it's calculating the mass based off of that velocities. And what does this mean? In your analysis, you should discuss how the net force and its parallel and perpendicular components are different from the rate of change of momentum and its parallel and perpendicular components. Think about the rate of change of momentum means and what net force means in terms of things you consider. So basically this means that you can observe changes in momentum with your eyes and measure that. However, you can only understand that net force is the cause of those changes. You can't actually see the net force. So like when you look at the model, you don't actually see like the net forces. You can only see the changes in momentum. And so it also asks, imagine a black hole whose mass you found was removed and a different black hole was placed in the same location. Assume the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? In other words, is it possible for you to find a value of the mass of a new black hole that is different from the mass you found originally? No, because the motion of the star remains unchanged and the motion of the star was used to calculate the mass of the black hole. The end. Thank you so much for watching my presentation.